Hello everyone. In today's lecture, we will study the different gear terminology which we started in the previous lecture. So in the previous lecture, we discussed some basic technical terms which were associated with the gear profile. So let me just revise some terms. For example, this is one of the circle of the gear profile. Let me draw some other circles as well, and then I will explain the whole geometry. That this is one of the circles. Okay, this is the third circle. This is the third circle. There were in total 4 circles in the gear geometry. So let me just revise those circles to you all. This is the third circle and the fourth one. And the fourth one. This is the fourth circle. Just above the lowest one. Fine. So these are the 4 circles. Now let me draw the basic teeths of the gear. So if I try to draw the teeths of the gear, that this is the first teeth of the particular gear, then the corresponding second teeth, then the third teeth, and so on. So this is the typical geometry of the gear. Now if we could remember, then this circle was called as this one, the outer circle was called as the, let me just make the pointing lines for all the circles. This outer circle was called as the addendum circle. This is addendum circle. The one below it is the pitch circle, and if you all remember that this is the important circle from where all the dimensions of a gear are measured. Then below the pitch circle we have the clearance circle. This is the clearance circle, and the lowest circle from where the tooth is started is known as dedendum. Okay, dedendum circle. Okay, fine. Now if we measure radially the distance of this outer circle with respect to this pitch circle, if we measure this distance, then this distance is called as the addendum. This particular distance is called as the addendum, and if we measure the distance of the lowest circle from the pitch circle, this one, radial distance, this is termed as the dedendum. This is termed as the dedendum. Fine. So this is termed as, this one is termed as the addendum, and this is termed as dedendum. Dedendum. Okay, this is dedendum. Okay, so we measured the addendum and dedendum from the pitch circle. From the pitch circle. So this is the important parameter. Okay. Now, this particular top portion of the teeth was called as the top land. This we already have discussed. And if we consider a point on this pitch circle, for example, from, let me consider one point on teeth number 1 and another point on teeth number 2 on the pitch circle. Mind it, it should be at the same location at the point 2. And if we measure this distance along on this pitch circle, this one, then this distance will be known as this particular distance will be known as the circular pitch. Let me write it here. This is known as the circular pitch, and let the diameter of the pitch circle, let me just write the diameter of the pitch circle from here to here, let it is represented by D, the capital D, and T represents the total number of teeths. Total number of teeths. Then this particular, then okay. So this is called as the circular pitch, and this circular pitch mathematically we can write it as pi d by t, and it is generally represented with PC. So this is the circular pitch. Pitch, we already know that in case of threads it is the distance between the two consecutive threads, and in case of gears it is the distance between the two consecutive gears measured on the pitch circle. So this is the circular pitch. Now this pitch circle is an imaginary pitch. You will not see this circle on an actual gear, but the gear is manufactured, is designed with respect to this pitch circle. Okay, fine. Now next we have the total depth. The total depth of a particular gear teeth is defined as the summation of addendum plus dedendum. Addendum and dedendum. So the summation of this particular distance from here to the dedendum circle. Okay, this called as the total depth. So practically it is from this point to this point. This defines the total depth. Now, as we know that circular pitch is defined as pi d by t. Now, here I am going to introduce one more term, which is the diametric pitch, and it is given as TD, and it is a ratio of number of teeth to the pitch circle diameter. One very common question is asked in some competitive exams, that what is the answer of multiplying PC to PD? So it is a very simple. Now you can write it as PC is given as pi d by t and PD is given as t by d. So this will come out to be as pi. So pi will be the answer. Okay. One more important term is there in the gear nomenclature, which is known as the module and represented by small m. It is given as the ratio of d to t. So this is a very important term. Just like the pitch circle diameter or the circular pitch or the pitch circle, this is again an important parameter which is kept in mind while designing the gears. Now, if we need to mesh this particular gear, for example A, with another gear which is, for example, is A is one gear which has some teeth on it, and another gear is B which has, and if we need to mesh these two gears A and B, then the circular pitch of A and B should be equal. Then only these two gears will mesh perfectly. Okay, so this is a very important term which should be kept in mind while designing the gears. So this is the circular pitch. Okay, fine. I hope it is clear. Okay, next, if we need to mesh some gear B to A, let me now draw that particular gear. So for that I need to erase this term. We'll write it again. I need to erase this term. This was the circular pitch. PC was pi d by t, and t is number of teeth. Fine. Now if we want to mesh this particular gear with some another gear, let me draw that here. That this is that particular gear teeth, and I want to have a good meshing between the gear. For example, this is gear B and this is gear A. Then there should not be much space between the teeth of gear A and gear B. Okay, let me draw it here to explain it. For example, this is one teeth profile, this is one gear teeth, and this is for the another case. For example, these are the teeth of a particular gear, and with these gears another gear is going to make a mesh, is going to make a mesh. So in the first case there is in the second case there is too much gap between the teeth of the one gear to the teeth of the second gear. Now this is too high, and this difference is known as backlash. This is known as the backlash. So backlash is defined as the difference between tooth space minus tooth thickness. Tooth thickness. So if I need to define it here, then we can remember that this was the tooth thickness and this was the space. Okay, so there should not be much space between the tooth thickness and the space. This is known as backlash. And if the distance is very low, then that will be too low. So an optimum difference between the tooth space and tooth thickness shall be maintained in order to get the good meshing of two gear teeth. Okay, to get the good gear teeth. Now there is one more term which is known as the pressure angle, which is known as the pressure angle. Now if I draw the pitch circles of, for example, two mating gears, for example this is the gear number 1 and this is the gear number 2, and these are the pitch circles. Okay, means this black one of this particular gear A and the pitch circle of the gear number 2, which are in mesh. Okay, so at particular distance, at this distance, this is the pitch circle of the gear B and this is the pitch circle of the gear A. So I have drawn them here. Now as these gears will rotate, for example this is rotating in this direction, then this gear will rotate in this direction. So at the point of contact between the gear A and B, a line will be drawn which will represent the line of action. So let this line represents the line of action, and if we draw the common normal to these two gears, if we could draw the common normal for these two gears, then an angle is generated between the line of action and the common normal Now this particular angle between the common normal for the two pitch circles of the gears with the line of action is known as the pressure angle. This is known as the pressure angle. So this was all about the different gear terms which are associated with a typical gear profile. Okay, So thank you very much.